today we're going to do some problem solving and create a basic change calculator. So first and foremost, let's start with a new empty file, and we'll just put our name of the file here. So we're going to call this calc change, and let's do this April 16th, 2016, and then we'll just do a quick thing. Puts hi, this is my change calculator. Just so we know that it's working. This is kind of our hello world into this. Let's save it now. Let's do change calc.rb. And no, we will purchase Sublime Text one day, but today is not that day. And then let's run it to make sure that change calc actually works. Okay, so Ruby's running change calculator. So the first step is we kind of want to we're not going to ask the computer for change quite yet, like what the amount is, because we want to start basic and just figure out what stuff is. So let's start out with an amount, and we'll just make that an arbitrary amount, like 321. Now you want to calculate how much you'd have to give back in quarters, dimes, nickels, and pennies. So you know, kind of have a to-do up here. Get amount from the user. And then, you know, we have break it down to quarters, you know, dimes, nickels, and then I guess pennies. But pennies don't really matter since we don't need to do that. So first and foremost, we want to figure out how many quarters will go into that. You know, so because in this case we should have, you know, 3 times 4 is 12, so we should have 12 quarters, 2 dimes, and 1 penny, and 0 nickels to get to this. So what we want to do is figure out how many quarters need to go into that. So let's just count them. So we'll create a count, and we'll set that equal to the amount, and well, quarters are equal to 25, so we'll divide it by 25, and that'll give us the number of quarters that evenly divide into 321. Well, not exactly, because we need to do 0.0 here. Actually, the float is going to kind of make it a pain in the butt, isn't it? Because it's not going to divide evenly. Well, let's see what happens. I can't recall exactly. So then we'll do puts count after that. We want to divide evenly, so we'll do 25. And then what we'll do is we'll times this by 100. So whatever the amount is, we'll just increase it by 100. So it gets to 321. So we can remove the decimal point and not worry about it. That'll make our life a little bit easier, I think. So amount times equals, so go times equals 100. So times equals an operator. It's the same as if I did this. You know, amount equals amount times 100. All right, so you know that's exactly the same, so we'll just get rid of that. So right now we want to make sure that's an integer, so let's just do amount dot to I believe, and we'll save it and run it and see what we get. So we should get 4 quarters, $12, 12 guess didn't come out exactly as we wanted. So let's troubleshoot this. Puts amount. No. And save that. And what do we get for amount? 321.0. I think that might convert it for us. No, it doesn't want to do that. So let's go to our handy dandy internet, because really what it's doing is taking that first thing, or that first variable, and because it's a float, you know, the decimal the first time, it's taken as a float. So we need to convert it to an integer. So I'll go Ruby convert to integer. It's probably something really, really easy. To int, yeah, that's pretty much it. To I, yep. And I think we could even do better, convert float to integer. Yeah. I guess you can round. We don't want to do that quite yet. We just want it to be an integer. So what we'll do instead of doing that right there is we'll just reassign it to itself. So I'll go amount equals 2i, puts amount, right, and save it. Okay, 321, it goes in, we get 12 coins. That's how it's easily done. So we know how much the number of coins are for doing this. So now to get the next level, because we have 3 quarters or 300, 12 quarters to equal 300 or $3. We now need to subtract that from the amount before moving on to the dime step, right? So let's go ahead and get rid of that because we know what these are here, and we'll just do amount, and we'll do minus equals, and that's the same as doing amount equals amount minus, right? So we'll do both real quick. And then we know the value of the quarters, which is 25, and then we will multiply them by the count we have. So that'll equal 300, right? So now amount should now equal 21. So let's go ahead and puts amount and save it. And we'll go ahead and run it again. I just hit the up key to do that when I'm in the terminal. It's kind of a cool little thing here. Now we got 21, so that's cool. So now we need to go to the next round, right? So, oh, and this would be 25 times count. Now this should evaluate to be the exact same thing. You know, if you follow the whole, please excuse my dear Aunt Sally, you know, thing you learned in like 5th grade about parentheses, multiplication, you know, exponents, multiplication, divide, whatever it is, because it's going to follow that arithmetic process. It's essentially doing this, you know, because it's going to evaluate the times before the minus. So that's why we don't need to worry about it there. All right, so now let's do dimes. We know the value of dimes, right? Okay, so let's just copy this, really. I mean, I don't see why we would want to do it over again. So we'll just change this to 10. And go 10, and what we can do is here we can go puts, and then we'll put the amount of quarters to print out. So we'll do, and this is kind of a fun way to do this. You can just do count quarters, and what this is doing, instead of having to concatenate strings and stuff like that, it's just putting the variable in here. So what's happening is the amount, or the count variable, is being put into this place. So that happens when you have the hashtag and the curly bracket, the variable name inside double quotes. It only works for double quotes, doesn't work for single quotes. So and that would be equivalent to doing this. Puts let's see here, we do count to s because we want to create it to a string, plus, and then we have a quote, space, quarters. All right. So if I do this and this, it'll print it out twice because it's the exact same thing. So we'll save it and we'll run it just to kind of prove the point here. So I got 12 quarters, 12 quarters. All right. So now we here are dimes, and we're going to figure out the amount of dimes, which is 10. And then we're going to subtract that from the number of we're going to do the exact same thing as we did before. We don't need to keep this line. It's just a repeat. Right? And then we'll do the exact same thing. So we have the amount divided by 10, which will give us, rounding off the remainder, should give us 20, and that'll be 2. So it'll be 2 dimes, and then we'll subtract that into it, right? So then we'll have puts. We can just go up here because I'm lazy. And we put dimes. All right. And now we're going to do the exact same thing for nickels. All right. And let's see here. Do 5, 5. Well, we'll call it nickels, right? And then we can do the remainder. Really is whatever the count is, and that'll be the pennies. So amount should then at this point, in our specific one here, there shouldn't be any nickels. Well, let's look at that. So it'll be 1, right? So 1 divided by 5. If we're rounding here, we're not taking that remainder in decimal form, which we're not because we're doing integers. It should be 0. So the count should be 0. 0 times 5 is 0. And then 0 minus amount, well, that's the same as it was before. So the count is 0, and the amount didn't change. And then because the pennies reflect just 1 cent, we can just do puts, and then do our thing here, and we'll just do amount pennies, right? And then our change calculator is complete, right? So we have 12 quarters, 2 dimes, 0 nickels, 1 pennies, or pennies, you know. I think what you can do in that sense, you go Ruby pluralize, and there's a cool little feature in there. Oh, I think it's only for Rails. Yeah. Well, the idea is that if you have a certain amount of people, like here, I don't think we can get this library into there. Sorry. So the idea with this function here is we can just pull it into here and then put the object name in. And if it's one thing, it's one person. And then pluralize, we have the word here, and put person 2 because we know the type. And it'd be 2 people, 3 users. That's pretty cool. I'm not sure what library this is in. Action View Text Helper. Polarize. Gem. I don't know if there's a gem for this. October 2009. Download Ruby Gems homepage. Oh, this hasn't been updated in 7 years. Look at this. Yes, I'm not sure if it would really be worth getting into right now. But so anyway, let's now get the input from the user, so we can have the amount and then the change, and we'll just subtract it and be all good. All right, so this should be fairly straightforward in getting this kind of stuff. We can just do so we have puts. That's my change calculator. Inputs. Enter in the. And we can, I think it'd be better if it was a print actually, because the puts has a return line or new line character. That's the new line character, and the print doesn't. It requires you to prompt right there. Enter the amount of change, right? Or you could have it even do a bill. So print enter your bill. And then you could do something like bill equals, and I think it's gets, and that should get it. And then we need to do a couple other things to make it into an integer. But let's see here. I think it's chomp. Chomp. And then we need to do the same through here. And then we have paid. Let's call this the paid amount. We'll get gets.chomp. So we don't know what the user is going to put in here, right? So ideally they'll be putting in a specific amount, and it could be, it should be a float, right? At least to the second significant digit. So we're hoping that they're going to put in something like, 2132, and then we're all hoping that they're going to put in for this over here something like 2200, right? So let's go ahead and then do this 2f, 2f, because it should come as a string, right? And then if it does do that to the, if somebody puts a number in here like 21.32, we want to, or 352.3, we want to round to the nearest significant digit. And in money, if you're working with money, you should know that you should always round up, even if it's 0.1. You know, it's kind of how a lot of these things work. I'm pretty sure you round up. Well, don't take my advice. This isn't for doing financial transactions. You really shouldn't have more than 2. So we'll just Google that real quick. So Ruby float, because it's what it is, significant digits. So we want to round to a specific one. So all right, so right here. So we want to round to 2 significant digits. So we'll get 1, 2. I haven't done this in a while, so I can't recall exactly. So the function is signifit. So let's go look at the API doc. So Ruby. Come on, where's the API doc? That's the one I want. Ruby doc. So we'll just do, we'll find it again. Mm, 2F, 2R. I don't think, how did this person do it here? Oh, they created their own function to do that. That's fine, you can do that too. Class, I guess there's a big decimal one. Let's see, round. Okay, so we want to round to the second significant digit, right? So round 2 will get us there. So if we just do round 2, that should get us there for each of these. And we'll go ahead and try it in both test cases. We'll leave them out as 2, and then what we'll do is we'll do puts, and then we'll do bill. Something like your bill is, and we'll do bill, and then we'll do puts, your paid amount is, and then we'll go paid amount, and then we'll do puts, let's see here, your, and we'll just do change equals let's see here, bill minus paid amount, because the paid amount should always be greater than the bill, ideally, if you're going to pay for it. So if in that case, if it wasn't, you know, we could have a nice if statement here where it was like if bill is greater than paid amount, then you could do like else, you know, puts, oh, I can't type today, pay more, oh geez, I really can't type, money, you cheapskate. Okay, and else we can do this, we can just do change here. Now in normal languages, because of scoping, change would be out of scope for the next function, because it would be released, but it's not in this case. So paid amount, what I would do is usually just do like change equals 0 to initialize it, and then your change will be and then we put change, right? And then because if And let's look at this again. If the bill is greater than paid amount, then we wouldn't want to do all the extra actions here. So what we can do is we can get rid of this to do because we're already doing that. And then we can go copy or cut and put that in here. And what we'll do is we'll make this nice and formatted. I don't know why Sublime's doing that to me, making it the indentation in Ruby is 2 spaces. It should not be. Yeah, that's frustrating. I don't know why it's making it. I can't do it that way. I think maybe if I go like that. Nope. That's a pain. Control Z. Let's make this nice and pretty for us. Oops. Control Z. Oh, jeez, man. I am just a mess today. Alright, so we know how much it's going to be. Let's just run it right here, even though we haven't changed it, and make sure everything works. Just check it. Enter my bill. So let's go 32.21, and we're going to enter the change. We're going to enter 23.00, and it says pay more money, you cheapskate, and then just exits out of that. So if we do the same program and we do it again, and we go 23. And then we have a change of 24. We should have 4 quarters, but it doesn't calculate that quite yet. So be negative 1. That's fine. So what we can do is just do absolute value on that, right? So we can do Ruby absolute value, and then is ABS. I saw it. Go back to it, ABS. So ABS, just click on it right here. ABS, we get an absolute value to this. So what we can do to this now is we can do more advanced thing is we can say, all right, the computed value of bill minus paid amount will be a certain integer, right? And it could be a negative integer. If we do dot ABS to it, which is a really cool feature of Ruby, to do this chaining here like we did to here, where it was get it, chomp the string, make it into a float, and then round it, because if you didn't do it, you'd have to do something like this. You know, bill equals gets, and it gets it, and then bill equals get, or bill dot chomp, and then bill equals bill dot 2f, and then bill equals bill. You see, this is exhausting already. I'm exhausted just thinking about it. And that would essentially be the same thing. So let's just copy this or comment this out so we don't have to worry about this. So if we save it and then run it again, so we have 24, 34 is our bill, and we'll do 44 here. The change will be 10, 0, and that's fine. So we still have it as a float at this point. So what we'll do is we'll take that and we will just take the change and set it to amount. Now we could change this all to amount or make this change into amount. We could do that instead. All right. So if we just do this, and then we take amount and put that in there and put that in there, that should make the program work. Now this is only going to calculate in dollars and I'm sorry, not dollars, but it's only going to calculate in quarters, nickels, and dimes, right? Well, and pennies as well. So if you wanted to do you know, 10s, 20s, and 30s, or not 10s, 20s, and 30s, what am I talking about? $30 bills, yeah. $20 bills, $10 bills, $5 bills, and $1 bills. Well, you would just do the exact same thing, but have it as greater values. So, well, let's run it right here and see where we get. just to make sure everything's working. So my bill, we're going to say it's $32.21, right? And we're going to have the amount, enter the amount of change. Why is it? That sounds kind of stupid. Amount you will pay the bill with. That sounds a bit better, I guess. It's more user-friendly, quote unquote. All right, so now let's do $35. Wow, look at that. Your change will be $2.78 and 9. And essentially what we get is 11 quarters, 3 dimes, 3 pennies, which makes sense. So we want to round this a little bit. That's a bit ridiculous, isn't it? So what you can do is, I believe what we can do is we can do round 2, and that'll actually compute it inside here, but not save it to the function, because we don't really care about that quite yet, right? And then the 2i we'll chop it off. So if we save that and then do that again, and we had what, 32.21, and we had 35. Yep. So the change will be $11.79. Does that make sense? Yep. Well, it did work. I didn't type in the right amount. This should have been 32 instead of 23. Yeah, but you know, what the hell. So if we wanted to do 20s, 10s, and 5s, well, all we have to do is this. So 25 cents. So if it was into $1, right? Let's get rid of this here, and I want to get rid of that there. What do you think $1 is going to look like? Well, if 25 cents is 25, it's not 0.25. We could just do the same here and just do 100, right? So 100, and then we have dollars. So I could do this into $5, right? We'll have to say $1 bill, right? And then this would be 500. $5 bills, right? And then let's just say, let's keep the comments easy for us newbies out there. And then if I wanted to do it a little bit easier, I could just say, oh man, let's see here. I could just do this. We did $5. Now we can do 10, 10, and then we have 1,000. Really, is what it is. It's 1,000 pennies. It's $10. And then we could do 2,000, which is $20 bills, right? Okay, so this is getting exhausting, man. I'm lazy and I don't want to do it this way. But anyway, let's just, we've computed it this way. What we'll do is, we don't want to save it. We'll save this. And then we'll run it again, and we'll have, okay, so let's pick a really big difference this time. We'll say we've got a 23, 21, and we're going to pay with a really obscure amount, like 73.90.78. All right, so we've got two $20 bills, 0 $5 bills, 0 $1 bills, 2 quarters, 0 dimes, and 1 nickels. So one of the ways we can also do is, I'll show you this in a little bit, is, so now we already know what we want to do, right? But this is taking like really actually a long time to do. You know, I wouldn't want to write this out a billion times. It'd be much easier, and let's save this version. So why don't we just start a new one, right? And we'll just copy everything into the new one, and we'll save this as change calc 2.rb, and change a little bit dyslexic there. So let's get rid of this junk, right? So we know what the bill is, we know what the amount of paid is. We're gonna round that off here, right? So we're gonna change the amount to an integer. But this part right down here, it just seems like it's the same thing over and over again, right? Except for this last line here. So, I mean, it seems to me like we could just put that into a function, right? So if we had the amount, so why don't we just do that? So Steph, we'll just call this, what do you want to call this? Change, and we're going to pass in the amount that we have, right? So the amount, and we're going to pass in the value of what it is. And we can even pass in the name of what it is as well, right? So we'll have end. And so what will happen here now, so I'll just do this one right here. So the count is going to equal the amount, which is right here. Oops. We'll just put this right here. We'll call it something different for scoping. Amount, the value, we'll copy that right there, value, and then we have the name. So we're just going to go same thing here, name. All right. So instead, each time, so we'll just try it with one of these, right? We'll do it with the nickels, right? So we'll just call it, and we'll say change. We want it to return something too. That's a good point. So we'll just put the amount left. Actually, what we could do is put it there, because the function should return the last line. So you could either do return, or it's just returning the last line here. So it's going to be what comes out of it here. So change is going to equal, so we'll do amount equals change, and we'll do the amount that we have, which we already know is amount, right? The value of what we're going to be doing is 5, is a nickel, right? And then the name of it, we're going to pass in a string, and we're going to call it nickels, right? So now if we comment out this entire line, the whole program should still work. And oh no, this is change calc too. So if you do Control C, it'll exit on. So we want to do change calc 2, right? So let's do 32, 23, 32, 32, and we're going to be playing with 42, 43, 43, right? No method found for change. That's interesting. Why is it saying that now? Did I not? Do I have to put this in there function? Change equals 0. Oh, it's because I have it up here. That's what it is. Change equals 0. So we want to get rid of that. Because no method defined for this one. Let's go ahead and put this in the top. That's probably what it is. Put this before everything so we know that it's there. There we go. So for this one, well, we didn't have a way to calculate nickels in that one. Let's just do it again. So do 32, 35, because we know it'll calculate a nickel with that one. It will do 40, right? 0 nickels. 4 pennies, 0 nickels. How does it come to that? All right, let's take a look at what we did wrong here. If we did this, right, wouldn't be the same. Let's just test and make sure. Control C, once you get that. So what was the bill? It was 32.35, and then it was 40 we paid, and it came out to 1 dime 4 nickels. So it must have rounded someplace. You know, we don't know where the issue is, where it's rounding, but we're 100%. Oh, wait a minute. No, that's right. That's right. I'm not sure what's getting the 4 pennies though. Because of 35, 65, so it'd be 2 quarters. which is 50, and then yeah, it's got a little bit of a rounding error in there. Some places rounding down. So anyway, it's not the function. It's just the amount entered. So there's a little bug in there, a little rounding bug. But we're not going to go ahead and we're not going to chase that down. I'm sure it has to do with how we're rounding someplace in here. If we rounded to 2, we should be rounding up or down. I'm not quite sure. But maybe if we did this, can we do seal to like 2 ABS? I don't know. But anyway, let's not sweat it. Let's just go back on the route we were on before and not worry about that. And we'll try to calculate nickels. So if we do the same thing right here, if we do this, we do it for dimes instead, right? And we commented out this part right here, and this part right here, and that part right there. We should have 10, and then we'll put dimes in there, and save it, and do the same thing. Let's Control C out of that. And we'll do 32, 35, and we'll do 40. So we have 1 dimes right here, and we have, if you notice here that I have a capital D here, I replaced the old one that had a lowercase d, so we know it's working. So we get the exact same answer here. So with this function here, this function which pretty much does everything that each one of these do, look how much code I can reduce. We can get rid of this right here. We can get rid of this. We can get rid of that. Oh my god, we're saving so much space. Alright. But, you know what? I want to be even lazier. Let's go ahead and we'll do a new one. We'll do change calc 3. And we'll just copy this all forward, right? So we have our function. And we've got a couple of cool things in here. But we already know what the value of everything is, right? So it doesn't make much sense to sit here and call it every time. What we could do is, instead of doing that, was we could have an array that did it for us. So if we did something like, this is a bit advanced, is let's just say we have an array, right? And what we'll do is we'll call this, this is more like a dictionary or a hash, but we'll just do 20s, and we'll do 20s, and we'll call that 2000, right? And then we'll do 10s, and we'll call that 1000, and then we'll do 5s, and we'll call that 500, and we'll call this 1s, and we'll call that 100, and then we'll do quarters, and we'll call that let's see here, we'll call it 25, and then we'll do dimes, and then we'll call that 10, and then nickels. Sorry, I've been spacing out a lot today. And we'll call that 5, and then we'll do pennies, and we'll call that 1. And then what we'll do for this is we'll do for each. So what we're doing with this is calling that each thing here. So we have an array with these values in it right here. So if we look at, let's do real quick here, Ruby array. You know, you can always refer to the documentation. So there's a couple different ways of having arrays, right? So the first one is kind of just an array equals these amount of things, right? So it's got the square brackets on it, and it's 1, 2, 3, 4, 5, 6, and each element you get in the array. So if I go to it goes 0, 1, 2, 3, or this is the slot number. So if you imagine like little hashes up here, so this doesn't have to be 1 in it, but whatever value, because this would be 98, 99, 100. But the index of it, which is the slot number, it always starts at 0. So 0, 1, 2, right? So this is slot number 2. So if you access slot number 2, In this case, you get number 3 because it's what we stored in slot number 2. I hope that makes sense. If you access slot number 100 in this array, well, 100 doesn't exist, so we get nil. If we have -3, it's going backwards, so it's going, let's see here, -1, -2, -3. So this is still 0, -1, -2, -3. That's fun. Anyway, and we can do ranges as well. So we can have an array of strings. We can insert stuff. We can shift stuff. These are all the functions and everything that it does, you know, which is a lot of fun. We can do some mapping on it too, right? So let's find out where I have it. I think what we're going to find it in is hashes. Hashes are very similar to arrays. All right, so let's just go. We'll go back and we'll go Ruby hash, right? So we have font size 10 and font family Arial. So what these really are here is we've got something that has a name and is linking to something like that. And this is the exact same thing, right? So we've got Jane Doe has a value of 10 and Jim Doe has a value of 6. So it's got 2 different values each for each slot in the index, right? It's a hash. So and with the colon in the front, then the equals and greater sign, kind of like a little arrow here, is the exact same syntax as this here, putting the colon and then the value. It's the exact same syntax, and we can get the options this way. So what we're going to be doing here is we're going to be looping through them. So that's why we have the each at the end. So I have, we'll do, and then we'll put my, we'll call this money, and that'll be the first thing. It'll be this part of it, and then we'll have the value. So just try to stay with me on this, and then we'll end. All right. So this right here, this loop is going to do this hash 20 times, or for each one of these. So it's going to go and it's going to loop through, and it's going to do this one and this one. So while it's looping, right, it's going to go ahead and it's going to put this value in here, and then this value in the value, right? So it's going to put 20s inside money, and it's going to put 2,000 inside value. So the way we can do this to kind of test it is we can just put it. So what we'll do is we'll just go ahead and do, if I can find that key, we can do money, right? And then what we'll do is equals, and then we'll give it the value. So like value, right? So what it should do is it should loop through, and it'll loop through how many times? 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, right? It's for each denomination of money, right? And we could also do it this way too. This would be the exact same line if it was written differently. If we did like my hash, or the Ruby syntax, Ruby style guide, it says hash equals this, and then our hash is going to be stored into my hash, and then the difference would be is we just do my hash money, or we can just copy the whole thing here, right, and do that. So what will happen here and here, so what will happen here is this will do it twice. So cancel. Yeah, we actually do want to save it, so we'll just call this change calc3.rb, right? And we don't really care about what goes in there. We don't care about what goes inside here. Oh, we do care about that because our if statement. So we want this, and we want that to be higher. All right, cool. So what happened here? So we have it printed out here, so 20s. So you can see what it did here. Let's see if I can make this a little bit easier to read. It started out here, 20s, and then it went for the first iteration or the first time through the loop, and it printed that out. 20 equals 2000, 10s equals 1000, and so on and so forth. And then it got done with each of those, and then it printed out here. All right, so here, and it did the same thing because it's the same thing over and over again. So let's get rid of this. Oops. Because we don't need it, right? It's just an example piece. So now instead of doing that every time, like, geez, that's a lot of, like, we know what the value of everything in the money is. So for each one, each denomination. And we have this nifty little function down here, which will calculate it for us. So what we can do now is just do this. So you can now say the amount, right? So we know what the money is, right? The money is right here. So let's just do money, right? And we'll just cast that to 2s just in case. I think it's the hash value in there, but we'll go ahead and make that 2s. And we have the amount, which you already know, and then we have the value, which is an integer. So we should be able to delete all this stuff, right? It should do it all for us. And then the pennies one, oh, well, that's kind of arbitrary because it's going to divide by 1 and it's going to do it, and it's kind of a waste to do it like that, but hey, it is what it is. You know, 5 divided by 1 is still 5, or 4 divided by 4 is still 4, you know. So let's do 34.2033, and we'll do 40, and then look at that. So it went through all these now, and it calculated it for us. 1 5, 2 quarters, 1 dime, 1 nickel, 2 pennies. And that's pretty accurate there. I'm going to stick with that. All right. So you know what now? What's kind of sticking on me is another usability thing. Is like, you know, when you as a person, you go, you know, if the cashier was this, if you were to give them, you know, $40 for something that costs $34.33, and they're not going to repeat back to you, you know, oh, you've got 0 20s, 0 10s, you know, that would be just ridiculous. Why would anyone tell you what you're not going to get, you know? That would be just a waste of time. So what we can do here is not print those lines. So instead on this, we could say puts this, which is what it prints out. We can have it only print out if it does not equal 0. So there's 2 ways to do it. So if count is not equal to 0, right? So exclamation mark 0 here. And what's it's doing here is, and I'll do this a couple ways, I guess, so it's easy. This is the same. So if it's, so we're saying print if the count right here. So print this if the count does not equal 0. So that's how I'm reading it in my mind and saying it, and that's actually how it's happening here. So that would be the same as, and we'll just, how about we just make it run for the sake of argument so you can see it. So we'll do 34, 33, and we'll have $40 of change. And so there we go. So the zeros are not printing out, right? So let's do it a different way to make it a bit more simpler. So we could say the same thing. So if the count is not equal to 0, right, then we will print. If it is equal to 0, right, we'll do the puts. So we're saying that, like, if it's equal to 1 or 5 or anything but 0, we're going to print it, right? So save that. We'll do it again, and we'll do 34.33 and 40, and we get the same thing. All right, so that's one way to do it. So, but we don't want to have so many different ways. So in Ruby, they've got this great, what you call it, this great function or conditional called unless, and it's the opposite of if. So the way if statements work is if whatever is true, then do this. So it's if this is true, then do that. So it's really if, and then what your statement goes in here. So if, like, you know, 1 equals 1, So that's a true expression right there. Then we're going to do whatever is inside here. So the opposite of that would be unless, right? So, and what that means is like it's only going to execute if it's false. So, geez, that's so. Unless 1 equals 1, so that's true. So it's not going to execute, right? That's kind of a weird double negative logic, right? I hope that's making sense now. So because it's not there, well, we can just kind of show you. So let's do count. So unless count is equal to 0, right? Because it's the opposite. So if count is equal to 0, right, that would be a true statement. And we're not going to execute on true statements, only false statements. So we could put that in there, and it would be the exact same thing as this right here. Because we're just flipping the negative here. So it's like instead of it's not equals, and then it's equals. And that'll be okay. So we can save it and prove that it works, you know. So it's 34, 33, and then 40, and it still works just fine. So that's a lot of fun, and it reads better in your mind now, unless it's kind of tough at first, because you have to flip everything. If you're a seasoned programmer, you can kind of see that it's, you know, it might be a little challenging, or just new to the programming game. It's a little challenging because you have to flip everything in double negatives. I always used to writing not equals to for like the longest time. If it's not equal to that, instead of unless it's this, you know. And what you're doing there is you're limiting a specific condition, really. Like, so we're gonna do this unless it is this, you know. It's pretty much the way I think about it. So let's go ahead and comment this out here now, and we'll put our statement back, but we'll use unless instead. So we can go ahead and copy this here, and then what we'll do is equals, and do unless count equals 0. So we're only going to print what we're going to print unless the count is equal to 0, right? We'll save it, we'll run it. So we'll do 34, 33, and we'll put $40 of change in there, and it's the same thing. All right, so I think my change calculator is just about done. I don't need to do much else with it. I think that it's going to calculate changes fine. We did have that little bit of issue of rounding like 1 cent halfway through, but you know, this isn't going to be used by anyone that's crazy important, or, you know, processing, you know, checks or anything like that. So I'll leave this stuff in here, and we'll post this all to GitHub, and I'll put the link in the description of this video so you guys can watch, and then that will help you kind of get a better thing. So if you want, leave a comment in the video comments. You know, you understand how YouTube works, and if you've got questions or concerns, you can try and you can definitely ask them. Anyway, have a great day, guys. Bye.